Here we have one more example which mentions that a gun is fired at an angle from the top of the hill 100 meter above the sea level. 10 seconds later, the bullet is found to strike the warship at a horizontal distance of 1000 meter from the gun. Means here the point of projection and point of landing is going to be at some difference. So let us see what exactly that particular problem is. So here we have a gun which is at the top of the hill. So from this gun, which is 100 meter above, or the height of that particular hill is given 100 meter. So this gun is going to be fired on this warship, is it okay, which is placed at a distance of 1000 meter, is it okay. Now let us see how this particular problem goes. In this problem we have to find out the velocity and the angle of projection of the bullet while striking the workship, is it okay. Angle of projection and velocity while it is striking the workship, is it okay here. That means at point of landing we got to find out velocity and angle of projection. So let us move ahead and see how this particular bullet is been fired from one place to the another place on the warship. So here this is the first motion, and from this will be a second. So the gun is being fired at an angle which is at the top of 100 meter above sea level, and 10 seconds later, after 10 seconds, the warship has been destroyed by that particular bullet, is that okay. So you got height of hill equal to 100 meter and distance of the gun from the warship, it is equal to 1000 meter. So let us move ahead. So initial velocity with which it will be projected, it is inclined at an angle of certain alpha. It is going to reach the warship within 10 seconds. So horizontal velocity will be u cos alpha and vertical velocity will be u sin of alpha. So consider the horizontal motion O to B, means from O to B we are going to consider the motion or horizontal distance. Here we know displacement in x direction is equal to ut plus half it square in x direction. Here initial velocity is given u cos alpha in x direction. Sx is what? Horizontal distance, that is 1000 meter, and g, that is the gravity in horizontal direction, is equal to 0. So substitute all these values. So Sx is equal to 1000, ux is equal to u cos alpha, and time is equal to 10 seconds. So S is equal to, here S is given equal to 1000. So u cos alpha is equal to 100. Got it? So here we have equation number 1. Now let us consider the vertical motion from O to B, and that distance is equal to 100 meter. The distance between, vertical distance between the gun and the warship is 100 meter. So Sy is equal to uyt plus half gt square. So here as we are talking about the vertical motion, so the g will be equal to plus 9.81 because it is in the downward direction or towards the gravity. Sy is equal to 100 and time g is equal to, okay, here g is equal to minus, it has been taken, and s is also equal to be taken minus. Why? Because it is measured below. If we measure displacement above, it is true, that is positive, but here the distance is in the downward direction, so it is minus. So let's substitute all those values. So minus 100 u sin alpha into 10 minus half 9.81 into 10 square. After simplifying, we are getting one more equation, that is u sin alpha is equal to 39. So from the horizontal motion and vertical motion between 0 to B, we have established two relation, that is u cos alpha is equal to 100 and u sin alpha is equal to 39. So once we have these two equations, we can perform certain mathematical operation on this, like adding it, dividing it, taking the ratio, whatever it is. So here I am going to take the ratio of both these two equations. So here from equation number 1 and 2, and their ratio gives you u sin alpha by u cos alpha is equal to 39 divided by 100. Is that okay? That is equal to 0.39. Therefore alpha is equal to 21.3 degree. Once we get this value of alpha, put it in equation number 1 or 2, you will be able to get a initial velocity. So here we are going to substitute value of alpha in equation number 1, and after simplifying we got initial velocity is equal to 107.36 meter per second. So here this is what is the initial velocity, but initial velocity is related to the point of projection. We are interested in finding out the velocity when the bullet will be striking the warship, means here what will be the final velocity. Is it okay? If Vb is the final velocity here, let us see that what is that particular thing. So we have found out at point B initial velocity is equal to 107.36, that is Vbx, and alpha is equal to 21.3. So here horizontal component of Vb will be what? Vbx, and vertical component will be Vby. So here we are just going to compare the velocities in horizontal and vertical direction. So here we say when the velocity is to be found out of the bullet while it is striking the warship, so horizontal motion of the bullet is uniform velocity motion, and horizontal component of velocity remains constant from O to B. Is that okay? Now therefore we can say horizontal component of velocity at O, that is u cos alpha, should be equal to what? Horizontal component of velocity at B, that is Vbx, means we can say u cos alpha is equal to Vbx. So u cos alpha is equal to Vbx. Got it? So here after getting this equation, put the value of initial velocity. U cos alpha already we have found out 107.36, alpha is already found out 21.3, that is equal to Vbx. So this is Vbx is equal to 100 meter per second. So this way we have found out the value of Vbx, that is the horizontal component of final velocity at point B. Similarly now we can have the vertical motion from O to B. So for that we are going to use a kinematic equation, that is Vb is equal to uy plus gt, that is V is equal to u plus gt. So Vby we can find out, you have uy is equal to 107.36 sine of 21.3. So substitute that, and g is in the upward direction. So here bullet is been fired upward, so g is equal to minus. So Vby is equal to 107.36 sine of 21.3 minus 9.81 into 10. So after simplifying I got Vby is equal to minus 59. Why it is minus? Because it is downward. So we have found out Vbx and Vby, but we are interested in this velocity in B direction when the bullet is going to fire the warship. Is it okay? So by the Pythagoras theorem or from the parallelogram we can find out Vb, that is Vb is equal to under root of Vbx square plus Vby square. Is that okay? So after substituting the value we got Vb is equal to 116.1 meter per second. So this is the way how we have analyzed this particular problem. Here you might have understood the point of projection was above the point of landing. So this is the way how we have to analyze the problem when this particular sort of the problems are occurring. So just go step by step, you will be definitely getting the answers which are expected for that particular problem. Let's see one more problem from the cricket arena. Here it says a batsman hits a Yorker ball with the velocity of 28 meter per second at an angle of 40 degree. So with respect to the horizontal, a player standing on the boundary line wants to catch the ball at the same level at which it was hit. Assume that the player starts running to catch the ball the moment batsman hits the ball, means the fielder is going to run at the moment the batsman has hit the ball. If player can run with uniform acceleration of 1 meter per second square, find whether batsman would be out or not. So this is a practical problem. Even every day we are watching the IPL, there comes this particular sort of a problem, and you might have seen the analysis of the problem. The analysis has been all done by the computers, and whatever probabilities of the batsmen are there or bowlers are there, they are all being shown on your screen within fraction of second. This is only because of the conversion of actual problem into a computer language problem and giving the results with the various assigned probabilities to the computer. So let us see what that particular problem here is, and this problem we are going to convert into the problem of engineering mechanics. Let us see how this particular is going to happen. So bowler is going to throw the ball. So after the bowler has thrown the ball, the batsman is going to hit that particular ball. So let us have the conversion of this actual problem into a projectile problem. So here is the ball which will be hit by the batsman, and it will be moving certain distance, and it is going to trace the path of a trajectory. Let us see how it is going to happen. What is given? Initial velocity of the ball with which it is been hit, and the angle of projection, or the angle with which the ball is going to get projected. Alpha is given, that is angle of projection, and boundary line is given at a distance of 90 meter. So basically, batsman standing at O is going to hit the ball which shall hit the ground at A, means point of projection is here, and some other distance at that particular point there will be a point of landing of the ball. Let us see that. And second thing, by the moment the batsman has hit that particular ball, the fielder on the boundary starts running so as to take a catch of that particular ball, and here whether we have to decide whether the particular player batsman is been going to be out or not. So here this is what is a boundary. So here initial velocity is given of a ball with which the batsman has hit, and inclination of the projection is also given. So here it reaches here and it will touch the ground. Is it okay? So this is what is a projectile, pure projectile problem. So with the given set of data, we have to analyze whether the fielder is able to catch the ball at a appropriate time and make that batsman out. So let us have the analysis of this. So as we know, the boundary is at a distance of 90 meter from the batsman. The ball has traversed a path of 0 to A. So this is going to be the range of the ball. This is going to happen within certain time interval, and that is called as a time of a flight. Second thing, the fielder was initially at point B and he has to move a distance of AB. So length of AB he has to move, which is undetermined yet. When we will be able to find out this length of AB? When we shall be finding out range. So 90 minus range will be the length of AB. Let us see how that particular is to be found out. Here basically the whole problem is consisting of two parts. One on the side of a batsman, and second on the side of a fielder who is trying to catch the ball in the air itself. Is it okay? So projectile path of O to A from the batsman side, and second is uniform acceleration of motion for the path AB or BA, that is by means of a fielder. So let us have the analysis of first of all path O to A, that is the path traced by the ball which was been hit by the batsman. So here we know range and as well as time. This is a pure projectile motion where the point of projection and point of landing are at the same level. So in that standard case, we have the standard values for R is equal to U square sine of 2 alpha by G, and here the alpha as well as U is given. So simply we have to substitute it and simplify it. We got range is equal to 78.78 meter, and the time of travel we can find out from the standard formula again, 2U sine of alpha divided by G. Again substitute the value of initial velocity, the angle of projection and gravity. You will be able to get the time of flight within which the ball shall be reaching up to point A. So here, in order to travel a distance of 78.78 meter, it took around 3.67 seconds. Is it okay? Now the moment the batsman has hit the ball, the fielder starts running from B to A. So let us move ahead and have the further analysis. Now second part of the problem we are going to take, uniform acceleration performed by that fielder to catch the ball from B to A. He has to run from B to A. So here we know length of AB is equal to length of AB we got to find out. We know what? Length of OB, that is 90, and length of OA, that is range. So substitute here 90 minus 78.78, the length of AB will be known to U. So it is equal to 11.22 meter. So this distance the fielder has to travel within a particular time, then only he will be able to catch the ball in the air. So that time also we have to find out how much time the fielder is going to take place to reach up to point A. So let us have that. Fielder has to travel a distance of 11.22 meter to reach at A before the ball touches the ground. So for that purpose we are going to take a first kinematic equation where the initial velocity of the fielder will be equal to 0, because before hitting the ball the fielder was standing at rest. The moment the ball was being hit, he moved with a uniform acceleration of 1 meter per second square. So here S is equal to 11.22 meter. Time taken by the player or the fielder to travel a distance of 11.22. Is it okay? So here, and acceleration is already given 1 meter per second square. Let us have the analysis from the kinematic equation. S is equal to ut plus half at square. So S is known to you, 11.22, initial velocity is 0 and acceleration is what? 1 meter per second square. We have to find out a value of t1. So let us substitute all the values, have the simplification, and after simplifying I got t1 is equal to 4.733 second. Is it okay? In order to have a judgment whether the ball will be caught in air or not, that particular thing we have to understand, and that is going to be the conclusion. Is it okay? Now how do we conclude? Time taken by the ball to touch the ground is equal to A, means, and the time taken by the fielder to reach A is 4.733 second. So the conclusion is not out. How do we conclude this? Because the time taken by the ball to reach A is 3.67. If the fielder has to catch it, he has to reach at point A below 3.67 second, probably 3.50 second. Then only he will be able to take the catch of that particular ball in air. So this is how we have to analyze all the problems. So with respect to the knowledge which we have got into this particular projectile motion, you might have understood that wherever the army is going to work, they have to shoot certain things. Their projectile and kinematic equations are very much important, as well as I have told you earlier that whatever statistical data is been fed into the computer, according to that the computer makes certain programming and will give you various options, as we have seen in this particular case, when we have seen that time travel from O to A after hitting the ball by the batsman is equal to 3.67, and if the fielder is going to take 4.733 second to reach up to A, so all this has been calculated by the computer and the result is being given as not out. Is it okay? You might have also seen whenever the bowling is been done, various angles and inclinations and the projectile motion traced by that particular ball are being analyzed, and at last when the third umpire was been called, he calculates by the computer and gives you the result of that particular batsman or that particular bowler. So what I mean to say out of this, whatever dynamics we learn, it is very important as far as the computer language is concerned, because whatever computer can do, you might have seen the time taken by solving the one problem, it is about 7 to 8 minutes, but for the computer it's hardly a matter of fraction of second. Once the input has been given, he will be giving out the output, but to make that particular program you need to have the better understanding of this dynamics, and especially in this particular projectile motion. So with this I will be concluding for this particular projectile motion. I have covered almost all the probabilities of the problem which we can see in the projectile motion. So with this I will be signing off on this particular object. Definitely do like, subscribe and press the icon button